So the experimental that the Ka of our experimental was lower, meaning a weaker acid. So a couple things to point out. One is that the stoichiometry of a monoprotic acid with the sodium hydroxide as a base, that stoichiometry is the same regardless of what acid it is. So whatever monoprotic acid we would take, we would have the same half titration volume. It would have taken the same volume. If I had the same molarities I was working with, regardless of the acid, we would have the same volumes. However, the concentration of the H plus at that, the volume would have been, the concentration would have been different. And so if you had a greater concentration of, let's say, hydrogen, then you would have had a lower pH. So a stronger acid would give you the lower pH at the half titration point. So, so saying this is that we had a weaker acid, so we had a lower concentration of H+. And what I didn't talk about when I did the experiment is when I was swirling my beaker, a little bit sloshed out before I got to the equivalence point, which means that I lost some of my acid. And so there was less acid for the base to titrate. I think that would have affected the concentration, which makes sense that then those values would have been, the pHs would have been higher. Now, even though we have this curve, it's good to recognize, not even though, it's good to recognize a monoprotic acid. If it was a diprotic acid, we would have had two bumps in our pH graph. It would have gone along a little buffer zone, little steep slope, and then it would have gone in what looked like another buffer zone, and then another steep slope. If a triprotic acid, there would have been obviously 3 of those bumps. Now, in identifying the half titration volume for these weak acids, the reason that we can do this with this method is that the pKa is specific to each weak acid. It is very specific. It is unique. So that's why we can use this half titration method to identify weak acids. The very last thing I want to mention is, of course, back to the not percent, but just error in general. You know that I am placing heavy emphasis on error analysis always. Some sources of error you'll have to talk about could be that maybe the concentrations of either solution were off. Maybe there was inaccuracy when you measured when you put in the 50 milliliters of the unknown acid. If you had any air bubbles in your burette tip, if you weren't careful about that, the parallax error when reading burette volumes, we should have talked about in class how you need to be looking straight across at the bottom of the meniscus, not a little bit above, not a little bit below, because that will affect your reading of that measurement.